Wait, I forgot to share the textbook. Alright, it's 8 p.m. so we can start the class. So today we are going to learn a very new topic, and probably for you this topic is pretty hard, but I could teach you some techniques for how to do it. So let's continue to the first subtopic, 4.1 law of indices. So anyone here know what is the law of indices? Do anyone here know? Oh wait. Tak ingat. It's okay. I can teach you all. So let's recall back the law of indices. So yeah. So I'm going to write law of indices. So what's law of indices? So at first we have the a to the power of m multiplied by a to the power of n, and this is equal to a to the power of m plus n. So this is like you add the exponent where you multiply to each other, and also same to divide, and a to the power of m divide by a to the power of n equal to a to the power of m minus n. And the third one is when you raise the a to the power of m to another power, which is n, this will be a to the power of mn, which is m multiplied by n. So another is law is anything to the power of 0 is 1. No matter what, like 2000 to the power of 0 is 1, x to the power of 0 is 1, x to the power y to the power of 0 is 1. Anything to the power of 0 is 1. So and the next we got the a to the power of n is the nth root of a. So let's say 8 to the power 1/3. What does it mean? This actually we're finding the third root of 8, which is 2. And and for the last one is like combine. So a to the power of m over n equal to the nth root of n, the nth root of a, and then the a is raised to the power of m. So any problems here? Alright. So now we have know the law of indices, and we're going to check the textbook for actually this subtopic is like nothing else because you learn, or like you learn at Form 3 already what. So in this you're going to learn how to simplify and how to do something. Yeah, like simplify this. The 5 to the power of 3x multiply by 5 to the power of x divide by 5 to the power of negative x. So let's copy the question. Wait, this is a, right? Wait. So this is a cell practice. 4.1 it is a, and the question is find the power of 3x. Multiply by 5 to the power of x, or divide by 5 to the power of negative x. Let me double check.
Okay,
Okay, this is correct.
So
So let's simplify this.
So we have
a power.
We had
We had both of the we have both number which has base of 5.
So we can
easily do that. We can just add the power like we did right here.
So
So
this is
equal to 5 to the power of 3x plus x.
and then
And then
what do we call
again when we divide?
When we divide,
we minus, right?
But this is minus.
So
we need
to minus
negative
x.
So
So this is equal to 5 to the power of 3x.
and then
And then this cancel. So this just become 5 to the power of 3x. And just like that. Nothing else.
So
So
this is the answer.
this is the answer. And
I got
another book. I got from my book.
So this
is the question. We need to simplify this. This got a little bit harder.
So this
is extra.
So we got
5 to the power of 2x minus 4.
This
is the exponent. Don't misunderstood. Divide by 125. 125 to the power x and equal to wait.
I think
let me write this to another place. 5 to the power of 2x minus 4. 2x minus 4 divided by 125 to the power of x. And this equal to 25 to the 1 minus 3x over 5 to the power of x plus 1.
So how do we
simplify this? This looks pretty complicated, right? But you can tell that
this is 5.
This is 5.
This 25.
This 25. This 125. This are actually all the powers of 5.
So what is 25?
So what is 25? This is actually 5 squared. And this is 5 cubed.
So
now we can simplify
by
using this
method.
This.
So
how do we do?
We copy
the upper part first. 5 to the 2x minus 4. This is not negative. This is a 5. 5 to the power of 2x minus 4 divide by this is 5 cubed.
So this
is 5 cubed
and
then raised to the power of x. So
when we
raise to something, we multiply it.
So this
actually can be written as 5 to the power of 3x. 5 to the power of 3x. And just like that.
And then
the right side, 25
is also
5 squared. So this is 5 squared.
And then
everything
to
the power of 1 minus 3x.
So 2.
So we can just multiply 2 with this thing.
So what
we're gonna do is we're gonna multiply 2 by 1. 2 times 1 is 1.
I mean 2
times 1 is 2.
And
then 2 multiplied by negative 3x is negative 6x.
And
then just divide by 5 to the power x plus 1.
So
now
everything
is base 5. Looks very simple. Everything looks so simple now because they are the same base 5.
And
now we can do the divide. We can do a division. What do we tell?
How
do we do again?
We
need to
minus
like this minus.
So
copy this. This is actually equal to 5 to the power of 2x minus 4 minus the 3x. And this is also the right side is equal to 5 to the 2 minus 6x minus the x minus 1.
This is
minus x. Negative x plus negative x is negative 1. Negative 1 times 1 is negative 1. So that's how you got x minus 1.
And then
this just become 5 to the power of negative x minus 4. Negative x minus 4. Negative x minus 4.
And the
right side will be negative 7x. 5 to the power of
1 minus 7x. Okay, so
Okay, so look
at this.
at this.
These are
These are same. This base by this base by. This means that this
is equal
is equal to this.
So
So
we can
we can write them
by
by comparing
negative
x minus 4 is equal to 1 minus
7x.
7x.
And then we put,
And then we put the x,
and then
and then we put the 4, we get 6x equal to 5,
and
and x equal to 5 over 6. 5 over 6.
And that's the answer.
And that's the answer. So far, any questions?
Any
questions?
Did
Did anybody confused? Alright. So I got another question that looks pretty hard. Maybe at the first sight you say it's possible to solve it, but I will explain it. So let's look at the second part of the extra question. So we got 4 to the power of x minus 2 to the power of x minus 12 equal to 0. Okay, so look at this. How do we solve this? We don't have anything that we can do.
Do you have
any idea?
We need
to solve for x.
Use
log.
No,
not yet.
We
we don't need to use log yet. We are using the power indices.
Alright,
it's okay. So I will explain.
So now
look at this 4.
What is 4?
What is 4? 4 is 2 square, right?
4 is 2
square, right? So we can write this as 2 square
to the
power x.
And then
minus 2 to the power x minus 12 equal to 0.
So
now we have this.
We have
2 square to the power x. Now what do we do?
So
now
look at this.
Look at this thing. Okay. So you see, so 2 to the power 2 multiplied by x. So when we raise the 2 square,
we get
2x, right?
So this
is actually equal to 2 to the power 2 times x.
But did
you know
this
is actually equal to x multiplied by 2 too?
So
we can write this as 2x squared.
So this
is equal to 2 to the power x and then square. So let's clear this and then we simplify
by writing
like this.
So we got
2 to the power x
and then
square
minus
2 to the power x minus 12 equal to 0. Okay, so we got our second step done.
So do
you all have any idea how to do the first step?
Is this
looks familiar?
Look at
the second power. Alright.
It's okay.
This is actually a quadratic equation.
How
do I know?
So I will let y equal to
the power x.
So we're going
to substitute all to the power x into y.
So
look
y
square
minus
y
minus 12
equal to 0.
So now
we got the quadratic equation.
And we need
to solve for y.
For now. And then
we factorize. Negative 4 plus 3 is 12. I mean negative 4 plus 3 is negative y, so yeah. So we got y equal to 4
and
y equal to negative 3.
But what this
means, y is also equal to 2x to the power x.
So we're
going to rewrite this again.
So
to the power x equal to 4 and to the power x equal to negative 3. About x equal to negative 3.
Okay, so first
we look at this.
Look at this thing. How can
anything raised to a power get negative?
It's
It's impossible, right?
So
it's totally impossible to get a negative number after you exponent something. So wait, I have a question. Where to know you use y? Actually, this depends on you, lah. So look at this.
You can
You can tell it's a quadratic equation, right?
that I can
I
tell
can tell
because
because we got the
the
x squared plus x plus c, ax squared plus bx plus c stuff. So
I prefer
I
that
prefer that
if you're like
if you're like
confused
confused with the
like
steps,
you don't
like you don't
understand,
understand,
you can apply
you
it
can
in every
apply it in
question.
every question.
Well,
Well, depends
depends
if got question like this,
if you got the
if
format
got
like
the
this.
format like this.
So when you
So
see
when you see
next time you see
to the
to the
power
power
of
of
2x,
2x, you need to
you need
be
to be
aware lah,
aware lah,
because
because
sometimes
sometimes it might
give you this
give you
trick.
this trick,
It might trick
it might
you.
trick you.
Yeah.
Yeah.
At the
At
first
the
time, I
first
also
time I
confused
also
too.
confused too,
But now
but now
I do many
I do
questions.
many
I
questions
understand
I
lah.
understand lah.
So
So
now look at this.
now look at
This is
this.
not
This is
possible
not possible
because
because we know that nothing
can
can
you can
you
get a
can
negative
get a
number
negative
from
number
raising to
from
about
raising
x.
to
Not
about
even
x, not
negative.
even negative.
So
So
this is
this is
ignore.
ignore.
This is ignore.
This is
And now
ignore.
we have this.
And now we have this
To the power x equal
to
to
the power
4.
x equal to 4.
So
So
what is x?
what is
Very
x?
simple,
Very
right?
simple, right?
X is
X
equal to
is
2.
equal to 2.
That's the answer.
That's the answer.
If you
If you
sub
if
2
you
to
sub 2
here,
to here,
you just get
you just get
16
16 minus 4 minus
and
12, and that's equal to 0.
And that's it.
And that's it.
That's
That's
pretty
pretty
much
much it for the indices. Nothing to do. So
I will
I will
go
go
to
to
4.2
4.2, the cert.
So
So anyone have question before I move to 4.2?
Anyone
Anyone like
confused
confused how to do?
like
Like
everybody okay?
everybody okay?
Can I move
to
the
the cert?
Alright.
Alright.
Seems like
Seems like everybody is okay.
Now
Now I'm going to move to 4.2, law of cert.
so fast.
So fast, 15 minutes only. I'm going to use another different color. Okay, so now we're going to 4.2. Laws of cert. Okay, so in this chapter,
you
will learn about
the cert
the cert or the radical form. What is a radical?
This is a
This is a radical.
like
Like the square root stuff. This is radical. Sometimes the question doesn't want to give you square root. It's just say radical. So you need to be aware about this. This is called radical. This square root. Okay. So now you're going to learn about what is a radical, what is a cert, and condition for cert, and then you're going to learn how to do common, how to rationalize, and then you're going to learn how to uh convert the recurring decimals to the to a fraction. So now I'm going to introduce you with the law of cert first.
So
So don't worry, I will go
as slow
as slow as possible.
So
now
what is a cert?
what is a cert?
So
cert
is like
is like is you cannot
we cannot
we cannot write it as a to the power b,
where
a, b are integers,
and
and b is not equal to 0.
So
the cert you cannot write the cert
as the
as the
fraction
fraction form. So for took an example like cert 2.
What is cert 2?
What is cert 2?
Cert 2
is
you can type
you can type the calculator 1.4142 and then blah 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 stuff, right?
How can
You convert this into the a over b form? Like
it's
not possible, right?
So
when you met this is called a cert.
This is
a cert.
So we will
go textbook for further information.
They will
teach you and let you determine what is a cert and what is not a cert. So now okay, so cert cert is a bigger range for irrational numbers. So cert is also known as irrational numbers. So cert pi, or I mean cert 2, cert 3, or cert 5,
3 sub 11, like when you hear cert,
mostly
mostly
is an irrational number.
So
So what is irrational number? It's actually, like I said, you cannot be written in the fraction form or a to power b.
as shown
As
here.
shown here,
See, look at
see,
the
look at the
recurring
recurring
decimal,
decimal
0.3333,
0.3333,
and you can actually write as 1 over 3.
So
So
1
1 over
over
3
3
is
is
not
not
a
a
cert,
cert,
it is a
it is a
irrational
irrational
number.
number. I mean, it is a rational number because
you
you can
can
write by
integers.
integers.
So
So
look at this
look
table
at this
here.
table here.
Look at the
Look at the cert 3, cert 3, simplified number.
and
And the decimal is 1.7320508, blah blah blah.
and
And you cannot write this as the you cannot write it in the form of
fractions.
fractions. So this is a cert.
And look at this,
And look at this, cert 1 over 4.
the square root
The
of
square
1
root of 1 is square root of 1,
and the
and the below part,
square
square root
root
of 4
is 2.
is 2.
So
So you get 1 over 2,
and
and
0.5
0.5 is not cert because
you can
you can
write
you can write this as
fraction.
fraction.
1 over 2,
1 over 2 is a fraction.
And look at
And look at the third root of 11.
Look at the number.
Look at the number.
It's impossible.
It's impossible, so you cannot write this
as
as the fraction form. So
the third row
the third row of 11 is a cert.
And look at
And look at the third row of 3.
The third
row of 3 is 3.
And 3
is not a cert because it's an integer or a whole number. And
same to this.
same to this.
This
is also not a cert. This is also a cert because it cannot be written as fraction.
So now I'm
going to teach you about all the law of cert first. So
we have
law of cert.
Where you
multiply the cert A
by
cert B.
This
is actually equal to cert AB.
It's like
it's like multiplication. Like 2 times 3 is just 2 times 3.
And then
same as division. Cert A divided by cert B is equal to cert A over cert A over B.
And just
like that.
And
we need to know that a very important fact
that
A and B must be greater than 1 or greater than 0, not 1, sorry. Greater than 0
or
equal.
Because
if a cert
if a square
if a square root
the
inside number is less than 0,
this means
that
the
number is not possible to construct. Like
how do you
multiply two things and then get a negative number?
You
cannot multiply two same things and get a negative number, right? Unless the imaginary part, some really complex stuff like that. So
that is
the cert.
And
that's all of that.
And
then
if you
raise the cert to the second power,
it's
actually equal to A. So
it's not
plus minus A.
So
don't confuse.
Many people
will think that if you square the cert, you will get plus minus A. And this is absolutely wrong.
So you
will just get A. Okay.
So now
end of the introduction. Now we're going to learn how to rationalize. Okay. Wait.
What's so fast?
So fast? Already? Rationalize is here.
Okay, so we're
going to learn how to rationalize first. Wait. Let's do an example from the textbook.
Okay,
now we need to write the following as single cert. I'm going to do H cert 5 multiplied by cert 6 over cert 3. Okay, so this is 4.4. This is wait, I changed to green. So we do H cert 5 multiplied by cert 6 divided by cert 3. Cert 5 multiplied by cert 6 divided by cert 3.
And
And
now
look at the cert 6. What can we do? We can split the cert into two numbers.
It's like
It's like factorizing
the prime
the prime numbers, like
using the
using the prime number factorization to do this question. And so this also can be written as 5 multiplied by cert 2 multiplied by cert 3
over
cert 3.
And look at this,
this and that cancel.
So
What we get?
we get
only cert 5 multiplied by cert 2, which is cert 10.
And that's the
And that's the answer.
I will try
to do one more question.
Okay,
for the G part, let's do the G. The G. Okay, so cert 20 over cert 5, right? Yeah, correct. Okay, so what do we do? We're still the same. We're going to split the 20 into two numbers. We know that 20 is a multiplier of 4 and 5, right? 4 times 5 is 20. So this 5 and this 5 cancel. Now what we left? We left only cert 4. And what is cert 4? The square root of 4 is 2.
And 2 is the
And
answer.
2 is the answer.
So now
I will teach you rationalization. Rationalize. Okay.
This
is the rationalize.
Now
it looks really complicated, but don't worry. It's actually having a very simple concept only. So what is the concept? I will tell you right now.
So
in the textbook, based on textbook, it tell you need to eliminate the denominator by multiplying the conjugate. So what's the conjugate? Right. Conjugate.
So I will
write here. This will be a new part. Rationalizing.
So we need
to multiply conjugate.
So do you know
what is this?
Do any
of you know what is this?
A square
minus b square can be written as,
if you
factorize,
everybody
know, right?
Is
equal to
a
a minus b multiplied by a plus b. So
if you
multiply this two, you will get this.
And why we need
to do this?
Because we need
to cancel out the cert.
So
when we have like cert 3 in the denominator,
we don't like
we don't like the denominator. We don't like the cert for some reason. I don't know.
So
to rationalize this, we just need to multiply the conjugate.
At this case,
because cert 3 is nothing.
So
we just multiply both sides by cert 3,
the top
and the bottom for cert 3. Because this is
equal to 1.
to 1,
So
nothing will change.
And
when you do so,
you will get
cert 3. 1 multiplied by cert 3 is cert 3.
And
the cert 3 square
is
3.
So that's the
final product or the answer.
And that
is the rationalization.
So
let's get to a hard part.
We need
to rationalize
something
difficult.
Okay. Let's do a question. Okay, this.
Okay, let's do. Let's do F first, right? Let's do F first.
Yeah, correct.
It's
A
minus b multiplied by a plus b.
That will give
you a minus b square, which is not what we wanted.
So yeah, but
good try.
This
is self-factor 4/7. Up. So
practice
this
4.7.
4.7.
Let's write
Let's
OG.
write OG.
We do
We do
F. Oh, we do
F.
F
Oh, we
first.
do F first. F.
3 plus
3
sub
plus
2
sub 2 over 5 minus sub 5.
3
3
plus
plus
sub
sub 2
2
over
over
5
5
minus sub 5.
Okay.
Okay.
So now let's
So
start
now let's start
simplifying.
simplifying.
So what we're going
So
to
what we're
do?
going
We're
to
going
do?
to
We're
multiply
going
the
to multiply the
conjugate.
conjugate.
What's the conjugate?
What's the
Look at
conjugate?
this.
Look at this.
At this case,
At this case,
if you got like
if you got like a minus b here,
what
right?
you need to
What you need to
multiply
multiply
to get this?
to get this?
What we need to
What we need
multiply?
to multiply?
We need to
We need to
multiply
multiply by the conjugate of this,
which is
which is
a plus
a
b.
plus b.
Because when we do
Because when we do this, we will end up this result,
and this
and
will
this
cancel
will
out the
cancel
log.
out the log. I mean the
This will cancel
this
out
will cancel out
the
the third,
because the square
because
will
the
cancel
square
out
will
the
cancel
third,
out
and
the
we will
third,
get
and we
a
will
whole
get a whole number
at the
at the denominator.
So let's do
So
it.
let's do it.
So
3 plus sub 2 over 5 minus sub 5.
and then
And then
multiply
multiply the top and the bottom by the 5 plus sub 5.
and the
And
bottom
the bottom is also the same, 5 plus sub 5.
And we're going to
I'm going to erase this first. What? Sebab apa kena darab tu, sir? We multiply like that because we need to get this.
we need to
We
get
need to get a square minus b square.
Why we need this?
Why we need this? Why we need this? Why? Because
we need
we need to make our whole denominator only one number.
So
So ini a over b. Ini mesti nombor. Nombor.
Tak boleh
Tak boleh dalam set. Boleh understand?
If you
multiply by the conjugate,
we will get
the bottom will not be a number anymore, it will be a full number.
Okay.
Okay. So let's continue. A. So 3 plus sub 2 multiplied by 5 plus sub 5.
And the
And the bottom will be a square minus b square. What is a?
This is the A.
This is the A.
This is the B.
This is the B.
What is
A?
A
A
is
is
25.
25. A square is 25.
And B
square is 5 sub 5
multiplied by 5,
which is the
5.
5.
But I'm
But I'm going to write this
for
for better understanding.
And then
now we expand the top bottom part, the top part.
3
3 multiplied by 5 is 15.
And
3 multiplied by
sub
5 is 3 sub 5.
And
then plus
5
sub 2 plus the sub 2 multiplied by sub 5
is
sub 10 because 2 times 5 is 10.
And
then the bottom
we get
5 square which is 25,
and
sub 5 square is 5. So now
we just
simplify this. The top cannot simplify already lah. So we just leave it like that. So it's just 15 plus 3 sub 5 plus 5 sub 2 plus sub 10.
And
And then everything divided by 20.
And that's
the answer.
Because
you cannot simplify further.
And
that's a product. The answer.
Let's do
something harder. The G
or
H.
Okay, we're
going to do G first. G. Okay. So what's the question again?
6
minus sub 3.
6
minus sub 3 divided by 9 minus sub 12. 9 minus sub 12. Okay. So before Before this, we need to know multiply the conjugate.
So the
So the
conjugate,
conjugate,
this
this is A,
is B.
this is B.
So this is
So
equal
this is
to
equal to
6
6
minus
minus 3
over 9
over
minus
9 minus
12.
12.
And then
And then
multiply,
multiply, because this is negative, we multiply by the positive part.
If
If
positive, we
positive,
multiply
we multiply
negative. If
negative.
negative,
If
we multiply
negative, we
positive.
multiply positive.
So that's how
So that's how you do the rationalization. So
multiply
multiply top and the bottom by 9 plus 12.
9
9
plus
plus
12.
12.
And this
And this become
6
6 minus 3
multiplied by 9 plus
12.
And
And
the bottom
the bottom
is
is
9
9 square
minus
minus
square root of
square root of
12
12 square.
So
So now
we're going
to
to
expand the upper part.
So
So
6
6 times 9 is 54.
And 6
And 6
multiplied by
multiplied by
12
is 6
is
12.
6
So 12.
and
And then
then
minus 9 times 3.
and then
And then finally, the negative 3 multiplied by
the
the 12. Minus 36.
And
And then over
the 9
square is 81.
and then square root
And then square root of 12 is the square root of 12. Square root of 12 square is 12.
So now we
So now we simplify.
This is 6.
This is 6.
And then the 6
And then the 6 sub 12 can be written as 54 plus 6.
And
And
12 is
12 is 4 times 3, right?
So
So we can write as 4 times 3.
And then
minus 9 third 3.
Then
Then minus 36. What is square root of 36? It's just 6.
So
So
the
the bottom part,
81
81 minus 12
is
is
69.
69.
And then
54 minus 9, what we get?
Wait, 6
Wait, 6 still not 9.
54
54 minus 6.
we get
48.
48
Plus
this
third 4 is actually 2. So 2 multiplied by 6 is 12. So this becomes 12 third 3 already.
and
And minus 9 third 3
all
all over
69.
69.
And
And then we simplify the
12
minus 9 is 3.
And
then this is not the final answer yet.
We need
to simplify
by
divide everything by 3.
So
So 48 divided by 3 is 16
plus
plus 3 over 69 divided by 3 is 23.
And that's the answer.
And that's the answer.
So
So complicated, and then added up simple answer.
So I guess
that's it.
And now I can teach you
how to convert the
how to convert
the
irrational
how to convert the recurring numbers into
a single
a single fraction.
Okay,
Where is that again?
Okay,
This part.
Okay, so
this basically we use the lesson we learned from chapter 3,
which is
the simultaneous equation, but much easier because we just use 2 variable instead of 3 variable. So
do how he
do 0.676767
and then
and then multiply by 100,
and
and 100n is equal to 67767 67.6767.
And
And actually you don't,
if you don't want
if you don't want to use n, you can use any number like A, B, C, D until Z you can use.
So
So
when you use
when you use 2 minus 1, we get
99n
99 n equals
67,
67,
and then solve for n,
67 equal to 99. Thus, 0.6767 equal to 67 over 99. If you type this in the calculator, you will actually get this thing.
So now,
So now,
I will do some
I will do some example. Let's say, okay, let's say 0 point. Let's start simple. 0 point 2. And this can also be written as 0.2 with a dot. What does this dot mean? This dot means recurring. Recurring is repeat, like repeating. So we can say 0.2 repeating. So this actually means 0.2222 equal forever. So I use x lah. So that x equal to 0.2222. And then if you multiply by 10, 10x is equal to 2.222.
And this
And this is the first equation.
This is
the second equation.
And we need to
do 2 minus 1.
And we got
9x equal to
this thing
minus this thing. Cancel out already. The 2.2222 and the 0.2222 they cancel out, become 2.
So what is x?
So what is x?
We
We got x equal to 2 over 9.
So now
we can write thus
0.2222
repeating
equal
to 2 over 9.
But what if
this case
1.43434
repeating?
What do we do?
What do we do?
Look at the
Look at the 1 here. We cannot just multiply by 10, right? Because it will gangu the 1.
So we're
going to separate the 1
and
the 4, 3, 40, 44.
So what
we can do?
We can do
as
this
equal to
1 plus
0.43434 repeating.
So now we ignore
the 1 first. We need to add them back. We don't forget the 1. So we're going to do this.
That x
equal to 0.4343 dot. And then just do the same. 100x equal to 43 times 4343 blah 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 blah.
And this
equation 1,
this
equation 2.
So
2 minus 1,
you get
99x equal to 43. And x equal to 43 over 99. But we're not done yet. Remember, we got a 1 right here. We need to add them back.
So
this is only 0.40. So
don't forget the
1
plus
plus
43
over 99
is equal to,
with that calculator,
1
plus 43 over 99.
Okay, we get
142 over 99.
So we can write
as 1.4343 blah 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 equal to 142 over 99.
And just like that,
that's the answer.
So any
questions before I continue?
Any problem?
Do you not understand why I multiply by 100? Why when multiply by 100? Why not 10?
Why
cannot multiply by 1000?
Any
question?
No, right? Alright,
it's okay.
You
can continue.
So this
last question is actually pretty special.
And why I call this
special is
this is
actually possible to come out in exam.
And
this can possibly make all students confused. So I'm going to make this 0.1234
So now
we're going to make this a fraction. But how? We cannot do anything. We cannot multiply by 10 because we will get 12 by 343434.
Oh wait,
I think that's a great idea. So before every so most students they will do like multiply by 1000 and then 12, 40, 44, but you cannot do like that. So now we need to multiply by 100 first.
So
So
remember this thing.
remember this thing.
Now
Now
we
we
need
need
to
to multiply
multiply
100.
100.
100.
So
So what this become? 12 point 3 4 3 4 3 3 4 3 4 and repeating
And look at the
and look
12.
at the 12.
This is
This is equal to 12
plus.
plus.
We're
We're
going
going
to
to
separate
separate the 12 again because
we want the
we want the 3 4 3 4 not the 12.
So we
So we separate the 12
plus
plus
0
0 0.343434 dot dot dot.
So how do we
So how do we do this?
We just
We just do the same lah.
X
X equal to 0.343434 and then 100x equal to 34 dot 343434 dot dot dot.
And this
And this is the first equation.
This is
This is the second equation.
So what we're
So what we're going to do?
We're going
to do
2 minus
2
1.
minus 1.
So
when 2 minus 1
we get
we get
99x.
99x. There x
is
is equal to 34.
And then
we get x equal to 34
over
over 99.
But that's not
the answer yet. Remember we have a 12 remaining. We don't forget this 12.
So 12
12
dot
dot 343434 is equal to what? 12 plus this 34 over 99.
So we press
So we press calculator.
12
plus
34
divide 99. We get 1222 over 99. So we got 1222 over 99. And that is still not the answer yet because remember
at the
at the first time we multiply by 100. We multiply by 100.
Now we need
to divide back.
So
when we divide by 100,
we get back
the number which is 0.1234 3434 dot dot.
And
this is equal to 1222
over
over 99. But we divide 100, just add 2 0 lah.
So
you can write thus
0.1234
before repeating equal to 1222 over 9900.
So that's the
solution.
If you type
this
in
the calculator, you actually get
0.1234.
So
any questions
before I continue?
Do you
all have any question? Okay. So
it's pretty fast
because
that's it
for the 4.2.
I
didn't expect
we need to
enter the logarithm so fast.
Okay, let's see
what do we miss.
So the first
we get to know the law of surd,
and then we
know what is the surd,
and then
we learn how to convert the repeating decimal into fraction,
and then we
learn the law of logarithm.
Oh wait, we can do this.
We can do the 2.
Okay. We can do
74.3.
We need to
determine.
I think
I can just do it here.
So
look at the A.
The cube
root of 127. Determine whether the following terms are surd. Give a reason.
So very obvious.
Very obvious. 127
is a surd
because the square root of
the
cube root of 125 is 5. So maybe if you add 2 to the number, you will get 5 point something lah. And this is a surd, so we can know that A is a surd. Give a reason.
So how to give reason?
Because surd
because the
because the cube root of
127
cannot be written as fraction, and that's the
only
answer.
And
And
then
then for the
for the B,
B,
you can
you can
type
type
a
a
calculator
calculator lah.
lah.
So
So
like
like
1,
1, 2, 5,
5,
and then
and then
and then press
press
the
the triangle thing,
the
like
hex
the
one,
hex one,
or
or
you can
you
shift.
can shift.
You can try
You can try a
hex,
hex, and then
1
1
over 4.
over 4.
So what you get?
So what you get?
So you get
So you get
1125
1125
multiplied
multiplied
by
by
to the
1
power 1
to the
over
power
4
1 over
is
4
actually
is
equal to
actually equal to
5.79
5.79
1 blah blah
1
blah.
blah blah,
And
and
we cannot
we cannot
we cannot
we cannot
write this
write this
expression.
expression.
So
So
this is a
this
cert.
is a cert.
We can know that
We
this is
can
a
know that
cert.
this is a cert.
So for the
So
C,
for the C,
64 divided by
divided by
729,
729,
and we raise
and we
that
raise that
to the power
to
of
the
1 over
power of 1
6.
over 6.
Okay,
Okay,
we get 2
we
over
get
3.
2 over 3.
This means what?
This means
This
what?
is not a
This is
cert.
not a cert.
2 over
2
3
over
is not a
3 is
cert.
not a cert.
Yeah.
Yeah.
Yeah, I saw that.
I saw that.
2 over 3
2 over
is
3
not a
is
cert.
not a cert.
So
So
because what?
because
Because
we can write in fractions.
Although
Although it's like
0.666
repeating,
but
but we can write 2 over 3 as cert.
So
So
this is not a
this is
cert.
not a cert.
Although
It's written as cert form, but if you want to simplify it, it's not a cert actually.
So for D,
So for D,
a very
very
obvious.
obvious
79
is a prime number.
So
So how can you multiply the 7?
How can you
How can you multiply 7 times
is
its
integer
integer and get a
whole
whole number?
Maybe we can
Maybe we can try 79 over 897,
and then
and then
we raise
we
to the
raise
1
to the 1 over
over
7 power.
we get
We get nothing but 0.7674 blah blah blah.
This is
This is also not a cert. This is a cert
because we
because we cannot write this as an integer.
So that's it.
So that's it.
Oh my god.
Oh my god.
We still have
40 minutes left.
I think
we can enter logarithm.
Do you all
Do you all okay if I enter logarithm already?
Do you think
it's too fast?
Or you
have any question to ask? Alright. If no problem, I am going to enter logarithm. Also known as pretty much like
hell
to you all.
Yeah.
Yeah.
When I was
When I was form 4, everyone also
really
really hate the logarithm.
Okay.
Okay.
Logarithm.
Loss of logarithm.
Okay, so before
we
go to
the textbook, I'm going to quick introduce you what is a logarithm. Logarithm. Okay. Change a different color. 4.3 4.3 loss of log
how to write
how to write logarithm? Logarithm, like that.
Law
of logarithm.
Okay,
so
we have
we have three numbers here.
We got
our log,
the
the log,
and then
and then this is the base.
This
This is the number
equal
to.
then
Then I can write a black pen.
equal
to a number.
So what
is this? What can we say from this?
If
log
C,
C,
if log
A,
we
read this as log A base C equal to B.
So
log A
base C
equal to B.
So
how do we pronounce this?
This
is log 3 base 2. So after this I will pronounce this like that.
So
I hope you don't confuse about.
So
when we said that log
A
A base C is equal to B, this means that
C
this means that
C
the power of B
is equal
to A.
Yeah.
C to power of B is equal to A.
because
logarithm is actually the inverse of 10 to the power x,
where we got
different bases.
So that's
That's
basically
logarithm,
and we need
and we need to know the
condition.
condition. We need to know the condition for those numbers.
So first,
So first,
we look
we
at
look at the a first.
Look at
Look at
the
the
A.
a.
So we know that
the a
cannot be
cannot be
0.
0. Why?
Why? Because let's
let's
say
say
a to
a to the
the
power
power
b
equal to
equal to
0.
0. How?
It's not
It's not possible.
Even though
Even though b is
we
0,
still
you still get 1 watt.
So
So
a cannot
a cannot equal to 0.
If
If a equal to 0,
this means that
b equal to negative infinity already.
So
So
and
and when a equal to 1,
this means
this means that
log any
any base,
I say any base,
not
not
just 10,
5
5
anything
anything
is equal to 0.
is equal to 0.
I say log 5
I say log 5 0, log 5 equal to 0,
the log 5
the
of
log
1
5 of 1 equal to 0,
log 6
of 1 equal to 0,
log
log
4000
4000 equal to 0,
log
log anything with the
if log
if
1
log 1 base anything is equal to 0, no matter what is x, it just equal to 0. Why? Because
x
x
to the power
to the power 0
1.
is 1.
We all know
We all know this.
Look,
Look,
see
C
the
power of b
is a.
is a.
So
So
C
C is x,
B is
b
0,
is 0,
A
a is 1.
C
C the power of b
is A.
is a.
This means that
This means that
x to the power 0
x to the power 0 is 1.
We just
We just proven that
in the law
in the law indices.
So
So
the rules
the rules of log are actually pretty different.
How so?
How so?
Okay,
let's look
let's look at the
addition for log.
Let's say
Let's say,
oh my god,
oh my god, this is too bright.
Let
Let me change the darker color.
That's
about 1. Okay.
Let's say
log
log 5
plus
log
log
2.
2.
So
So
if I didn't mention
nothing is written here.
What mean?
What mean?
If nothing is
If nothing is here,
this means that
we are in base 10.
If nothing
is written here,
this
is base 10.
If I
said 2,
it means
it's base 2 lah. If nothing, it was base 10. 100% base 10. I won't lie to you.
So
when we add two numbers,
let's
let's not do numbers first. Let's just do a and b.
So
log a plus log b
is
equal to
log
of what?
AB.
So
how
do we prove this?
We're going to
prove this thing.
Prove this
theorem right here.
So we
let x equal to a to the power m,
y
equal to
a
a to the power n.
This means
that log
x
equal to
I mean
log x base a.
When
you write the a, the end of the base is a.
Also, there's
one more rule.
I forgot
to mention.
It's
a very important rule.
Okay.
Look at this.
If C
is equal to a, let's say
C is
equal to a,
the B
is 1.
It doesn't matter.
Like log 5 is 1, log 10 is 1, log 10 base 10 is 1, log 2 base 2 is 1. Yeah.
And
also for the C. C when C equal to a, b equal to 1.
It's the same
thing like
a to
the power 1 equal to a lah.
When you
do the same thing, you just take log. So
I hope
you understand.
Remember this. When
the base is equal
to
the index
b
100% 1. When C is equal to the a, b is 1.
This
is very important
because this
can also trick you sometimes, and when you forgot it's a fatal mistake. So now I write log x base a. What mean?
This means
that I have to take the log a
of
m about m.
So
an interesting fact about the logarithm is
when
we have an index, we have the n right here.
We can put
this
to the front.
How to do this? We can put this to the front.
So
I can rewrite this.
Okay,
write it as how?
write this as
m
log a
a
base a.
base a.
So
So like we said,
log a base
log a base a
is what?
is what?
Not
Not
no need
to say
Automatic
that.
is
Automatic
1.
is 1.
So this is
So
just
this
1
is just 1
and multiply
and
1.
multiply 1.
No need to write
No
lah,
need to
because
write
we
lah
already know
because
it's
we already
1.
know it's 1.
So
So we do the same.
log a
Log
base
a base
y.
y.
I mean log y
I mean
base
log y
a.
base a.
It is n.
This is
This is
n.
n.
This is n.
When we take the
When we
base,
take the base,
we'll get n.
we'll get n.
So what we need to
So
do?
what we need to do?
Now we need to
Now we need to multiply
x with y.
x with y.
This means that
This means that
where we get
hold on, hold on.
Okay.
Okay. So now
When
when
a the power
a the
m
power m
multiply
multiply
a the power n,
we will
we
get
will get
a
a
the power m
plus n.
plus x.
This is n.
This is n.
This is n.
This is n.
Alright.
Alright.
We do this.
We do this.
So now
So now
we can write
we can write this as
like
the
law of
law of
indices.
indices.
A the power
A the power m multiplied by a the power n is 1. And this is what? There you go the element.
Yeah, when
we took the log.
we're going
We're going to write this at the left side.
A
equal to m plus n
and equal
to
a equal
to m
multiplied
multiplied by a to the power n.
And then if we take the
log of both sides, let me rethink something.
Okay.
I'm going to write this as x and y.
This
is x times y.
And
this will be
what is m?
Log ax.
And what is this?
And what is this?
What is n?
N is log ay.
And now
we have this xy equal to
a
to the power of this whole thing. And when we take the log of both sides, what do we get?
We take
the log a base a.
Log
a
xy. Now look at this.
Log a
base
a power of log a x plus log.
Oh my god,
why I keep saying why I keep right loy. It's not loy. Log ay.
Okay, so what do we learn? This and that cancel. When we have the same base as the c,
when a equal to c, automatic is 1.
So this
and that will cancel.
And what do we get?
And what do we get?
Log
a xy equal to what?
This whole thing
lah. Log a x plus log a y. And we prove it. That's how we prove it. Sorry, I took some time to think right here because sometimes I also jam when proving this thing. So sorry. Why? By the way, this is the proof.
And also this works
the same as the division. Log a
x
over y
is
equal to log a x minus log a y. Yep. So this is what we get. If we substitute
if
If
we
we substitute m to the base,
substitute
m to the power
a
the power m,
everything like that,
we will still get the same result.
just
Just the minus only.
Basically,
Basically, logarithm is the
inverse
inverse of
index
index that is somehow connected to the index, so it's very important.
And
And sometimes we need to use log to solve problems.
Okay,
Okay, so now
I'm
I'm going to show you
another thing.
another thing.
This
This is
where we got
where we got negative
before the log.
before the log.
Let's say
Let's say negative log AB.
This is
This is actually equal to,
remember that where we have
a power of something,
we replace
we replace the
we put to the
we
side,
put to the side, we put
at the front
at the front of the number.
So
So
if b is
if b is negative 1,
the negative
the
one
negative 1
will
appear here.
If b is
If b is negative 2, negative 2 will appear here.
So it's
So it's very simple.
So we can
write this as negative log a b equal to log of what 1 over b.
What if
What if it's n?
Why I
Well, I replace it as n negative n log a.
You
You just put the n here.
You put the n
Put the n here.
You got the n
here.
So
anyone below?
Do
anyone confused?
Is it okay?
Is it okay?
Well,
You can ask.
What do you
don't understand?
Which
part you don't understand? Alright. It's okay. I will continue.
Okay.
Satu over b tunggal jadi positif kursor. Why? Because the negative actually represents b to power negative 1.
The negative.
The negative. I choose another vibrant color.
Itu
b
kepala
negatif 1.
Dan
Dan jika kita log ini negatif 1 boleh pindah
ke
depan. Dan kita dapat negatif lah. Ini cara untuk dapat negatif.
So
jika kamu pindah negatif,
ini
jadi positif lah. Dan the index ini menjadi negatif. So faham? Understood? Alright. That's another principle.
Okay,
another thing right here is log
a
base b
is equal
to wait, I'm going to change different color first.
I think black
is kind of ugly. I'm gonna change different color. Red and blue is okay. Okay. So log a. This is red. B equal to what? 1 over log.
And then
the egg over here.
The b
become here.
How do we
got this?
Macam
mana? How?
I will show you
right now.
This
happens
without
we cannot know this without knowing the theorem.
What theorem?
The change base. How do we change base? Like I want to change the log. I want to change the base 10 to base 3.
Like how?
How do we do this?
Now I will show
you.
This is C.
This is C. C is the new base. Log C.
Okay,
log CA
equal to log. Wait. Log CB. Let me
rewrite this first. Log CA.
Okay,
Okay, log A base B equal to log CA over log CB.
So
So I'm going to
replace
it as colors.
C is the new
C
base,
is the new base, yeah.
log A,
base B.
and
And
A
A first,
then B.
then B.
So that's how
So that's how we do this.
And if
And if we substitute
the C
the C into B,
like
I'm going to change the base to log B lah.
This is log A.
This is log A. Okay. So now log log
A
A
B.
B.
Okay, now I'm
gonna change the base A to base B. Understood? Okay. I'm gonna change the base A into base B. C2 boleh letak apa nombor esok? C2 tak boleh negatif, tak boleh kosong, tak boleh satu.
Okay.
Okay.
Itu C
C tak boleh negatif,
tak boleh
negatif. Maksud
C have
to be greater than 0
and C
cannot be 1.
Okay.
So let's continue.
So I'm going
to change the base A to base B.
So
like the formula
is log
A.
Is
log B. Base B
over
log
B
base A.
Because
our new base is B.
And
we're going to do this first, then divide by this. Look. A B
log C
log CB.
Oh wait.
Ini B first. Log CAB equal to log CA over log CB. Log BB log BA. Ini B first. Baru A. Okay. So what can we observe? This equal to 1. This become 1 already. So equal to 1 over log B A. And also remember,
this is
nothing.
So that is
a principle right here.
So once
you know it,
once you know
a principle, sometimes
the question
they will ask you to prove.
They will ask
you to bukti
do
law of logarithm. Bukti macam mana? Macam mana buat itu? Macam mana log A plus log B equal to log AB. Kamu boleh rujuk buku teks lah. Dia akan
it will
show you the way. Where? Proving the base. I believe is like that. The same thing we do. X, y equal to a to the power p plus a plus q.
And we just
took the log a from both sides, and then we get p plus q.
So that's how you
get.
What's P?
Log x base A. What is Q? Log
Y
base A.
You can
replace the P and Q to other number lah. Macam A, B, atau XY juga boleh.
Okay, now let's
look at some questions.
Kita
cari. Ini. Apa ini? Self practice 4.10. Okay. Self practice 4.10. Okay, so what rules did it give? What did it tell us? Log 7 for log 4 base 7 equal to 0.712. So log 4 base 7 equal to 0.712.
0.1
7 1 4 2 7 1 7 1 2 0.712.
And
Another one,
log
log
log 5
log
base
5
7
base
is
7 is
0.827.
0.827.
Log 5
Log
base
5 base 7 is
0.82727.
0.82727.
Correct.
Correct?
Okay.
Okay,
So now we're
so
going to
now we're
do
going to do
1
1,
the A
the 8,
log
log 2
1
1,
and then 1
and then
4.
1 4.
So look at this.
So look at
What is
this.
this?
What is this?
This is
This is
actually
actually,
we can just
we can just rewrite
into
this
fraction
into fraction,
like
like
compound fraction.
compound
So we
fraction.
can write it
So
as
we can
5
write it
over
as
4,
5 over
right?
4, right?
And then
And then
we can
we
write this
write
as
this as
log 7
log 7
log 5 base
log 5
7
base 7
minus
minus
log
log
5
5
log 4 base
log 4
7.
base 7.
Why we can do
Why we
this?
can do this?
Because of this.
Because of this.
The loss of
The loss of
logarithm.
logarithm.
Yeah,
Yeah, look at this.
This
This
loss
thing,
of
loss of
logarithm.
logarithm.
Need to
Need
half
to half
because
because
we need to
we
use.
need to use.
Okay.
Okay,
Now we just
now
copy
we
lah.
just copy lah.
What is
What
log
is log
7 5?
7 5?
Is
Is 0.827.
0.827
0.827 minus
0.712. Log 4
0.712.
is
Log 4 is
0.712. So
0.712.
we just
So we just
copy
copy
0.712. And what
0.712.
we get?
And what we get?
0.827
0.827 minus
0.712.
0.712.
You get
You get
0.115.
0.115.
And
And
this is the
this
answer.
is the
Ini adalah
answer. Ini
jawapan.
adalah jawapan.
So let me
So
pick
let me
another
pick
harder
another
one.
harder one.
This
This
100.
100.
How to do
How to
100?
do 100?
This is C,
This is
right?
C, right?
Log base 7
Log
of
base 7 of
100.
100.
Yeah.
Yeah.
Okay.
Okay.
Look at this 100.
Look at this
What
100.
can we divide?
What can we divide?
What can we do
What
to
can
this
we do to
100?
this 100?
We can write this
We can write this as 25
times 4,
times 4,
right?
right?
And what is
And
log
what is log
AB?
AB?
Log AB is
Log
equal
AB
to
is
log
equal to log
CA
CA
times log.
times log.
I mean,
I mean,
log
log
AB
AB,
log
log
AB base
AB
A is
base A is
log
log
logs x
log
plus log
X
y,
plus
right?
log Y, right?
So
So we're just going to
do this
do this.
log
Log
25
base 7
plus
plus
log 4
log 4
base 7.
base 7.
Yeah,
Yeah,
that's like that.
that's like that.
And then look at this
And then look at
25.
this 25.
What is
What is
25?
25?
25 is 5
25 is
squared.
5 squared.
This is 7.
This is 7.
Don't confuse.
Don't confuse.
Okay, this is 7.
Okay, this is 7.
So
So,
this is 7
oh,
too.
this is 7 too.
Okay.
Okay.
So this is
So
actually
this
equal
is
to
actually
log
equal to
7
log 7,
5 squared
5 square
plus
plus
log 7
log
of
7 of
4.
4.
Log 4 base
Log
7.
4 base 7 lah.
So
So remember,
these two
these two,
you can
you
pindah.
can pindah.
So
So
2 log
2
7
log 7,
5
5,
2 log
2
5
log
base
5
7
base 7
plus
plus
2 log 4
2
base
log 4
7.
base 7.
So we have
So we have already
expressed the
expressed the
100
100 in
log
terms of
7
log
5 and
7,
4.
5 and 4.
We just need
We
to
just need to
substitute log
substitute
5
log
which is
5, which is
0.827.
0.827.
So
So
2
2
0.827
0.827
plus log
plus
4
log
apa
4.
log
What
4
about log 4?
0.712.
0.712. Okay.
0.712.
0.712.
What we get?
What we get?
0.827
plus 0.712.
2.366.
2.366.
Okay.
Okay.
I see the
I
last
see
one.
your last one.
Let's do the last one.
Let's do the
The
last one. The
donkey.
donkey.
Also looks pretty
Also looks pretty interesting,
but
but
it's
it's actually pretty simple.
6.
6.
Okay.
Okay.
Donkey.
Donkey.
If I
If I didn't remember correct, if I remember correctly, it's 0.25.
Yeah.
Yeah.
So
So
look at this.
look at this.
What can we tell
What
from
can we
this?
tell from this?
This is
This is exactly equal to
the
the thing we just said before,
the
the
reciprocal
reciprocal one.
Look at this.
Look at this.
Mana itu?
Mana itu? Mana itu reciprocal one? inilah ini. Log 1 will be jika kita remove n. So this become negative. Negative log AB equal to what will be. So we got 4, right? The b in this case is 4, right?
So we
can write this as what?
log 7
Log 7 base 4 negative log 7 4 solve terus equal to what? Negative 0.712. And before we get confused, the
you can
actually got the negative answer.
You can actually
got negative answer. Why?
Because
because when the index less than 1,
you get
negative, right? Macam about negative 1.
So
when
we get
a number, log A base B lah.
Let's
Let's say the number is 1.25.
The product
The product
ini
ini hasil ini
greater than 0. Must
greater than 0. Apa 0.99 saja negatif. Tapi
if we
put negative, we cannot put negative in the B because
I don't know
lah.
It's
just like that.
We cannot
put negative.
So
I hope this ends your
confusion.
confusion.
And
we got 11 minutes left. Let's try one more question.
We can
try kebat maybe.
Let's try
kebat. Without four figure table simplify ini log simplify log 1249 blah 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 blah. Okay ini what question again? This is intensive practice 4.3 log 1249. Hello. And this is number 4 log 1249 log 49 base 12 minus or plus multiply by log 64 then what 12 over log macam ni. Okay. And then we divide, right? Divide what? Log 7 base 16. Okay. So when you see this question, do not panic because there is always a way to do this. So now let's see what we can do. Look at this random number. You can see 7, 49, 16 something. Okay. So first we don't want perfect square. Apa perfect square? Perfect square tu lah macam A square lah. We don't want this. We only want basic. So what we can write from this? So let's simplify this first. Let's look at the first log. Okay. Log 49 base 12. Macam mana kita simplify ni? 49 is 2 square, right? 49 is 2 square. I mean 49 is 7 square. So log 12 7 square multiplied by what? Sadly we cannot simplify this. Twelve over ini 16 is 4 16 is 2 to the power of 4. 60 is 2 to the power of 4.
Okay.
Okay.
So now we have
So
this.
now we have this.
We're going
We're going to
to
put
put
every index into the front,
forward.
into forward.
So
So second step,
do our
do our log 2 log 12, 2 log 7 base 12 multiply by. Actually,
we can
we can write this.
we can write this
We can write this as log 64 12, and then we can also multiply by what? By how? Reciprocal 1 over
this
this
thing.
thing. What about this thing?
So
So the 4 we go forward become 4 log
what?
log what?
Log
Log 2 base 7.
Okay.
Okay, so now
log 2 base
log
7.
2 base 7.
Log 2
Log 2
ini 7
ini 7,
ini
7,
ini 2.
ini 2.
Okay.
Okay. Sekarang ini kita nak tukar base dan kita nak cari apa dan kita boleh hapuskan. Okay, kita tukar base, bahagi boleh tukar darab depannya. Ya.
So
Look at this. Because look at the log 7, log base 7. There is no log base. We got one log base 7 here, and we don't have log 12. So what we're going to do? We're going to like reverse the A and B. So
we use
this formula. Wait. Ini.
We use this.
Kita guna formula ini. Kenapa kita guna formula ini? Karena kita tak boleh buat apa dengan base 12. Look at this. There's no base 12. We only got 7, 64, and then a 7. And then a 7, actually we got base 7, so we can actually simplify.
So
let's do this. 2 multiply by
1
over what?
This is
log 7.
This
become 12.
Okay.
So now
this also
we need 64.
We also do
the same thing.
We do
the same thing.
Oh wait.
Never mind, we do first. Later we can simplify also. So log 64 base 12. S1 1 over log base 12 64 multiply by 1 over 4 log 7 2.
Okay.
Now let's see what can we simplify. Actually,
you know
this actually
we don't need
to do this because the first time
it's okay lah.
we can reverse we can undo also. But first let's look at this 64. 64 is 2 to the power of what? 2 to the power of 6, right? 2 to the power of 6.
You
have 2 over 64. So now
I'm just
gonna inverse this back. Wait. Stop. Multiply by ini 2 to the power of 6. And then we got 1 over 4 log 7. Wait, what? Log 7 base 2. And then let me look at this. Okay, we got log 12. Got log 12. These 2 and 4 can cancel. This can become 2. Okay. So log 12 7 divide log is 6. 6 log 12.
2,
and then multiply by 1 over 2 log 7 base 2. Does this look similar to you?
Because
Because it actually look like log CA over log CB, right? Yeah, it actually look like log CA over log CB, but we just this 1/6 this 1/6 we can just do like this lah. Multiply by this.
Look at this.
Look at this.
Log
Log
CA.
CA.
Okay.
Okay.
We call the
We call the formula.
log
Log
AB
equal to log C
B
B
over
over
log
log
CA.
CA.
So
So
plus
C is 12.
So this
So
is
this actually equal to
log
log
BA.
BA. Log B base A. So log B
log B log
log
E
E
base A.
base A. What is the base?
Base 2.
Base 2.
This
become this already. So now
we have
we have a final thing to do.
Reverse 1 over
Reverse 1 over 2 log
7
7 2.
And
And
you know we can
we can exchange base, right?
Ini
Ini
we do a
we do a reciprocal thing,
and then
we just do the reciprocal again. So log 2 7 multiply by
1
1
2.
over 2. It's okay.
I do
I do slowly.
1
over
log
2 base 7.
So if
you multiply the top and the bottom by 2,
this 2
will go up.
This
Will go here.
So
we got log
2 base
2 base 7 multiply by
2
over
2
over log
2
2 7.
This can
over here. Log
2
7 multiply by 2 log 2 log 7 base 2. 7 base 2 over 2. And wait. You simplify, right? This,
so
we just get
log 2
7 times log 2 7 multiply by log 2 7.
Let me
check the step first. Actually we overdo a lot of step already.
We shouldn't
have do that. Let me try again. This doesn't look very well. Log 4. block CA.
Oh wait, what? Okay, let's see the answer first, I think. Let's see the answer first. .3 intensive practice 4.3. For number 4. I wish we get 4 over 3. Oh, how do we end up here? Wait, it's whatever this. Oh. Alamak. Ui. 4 over 3. Sorry, I guess today we, because it's 8:30 already, so I'll do until here first, and later I will send a correct answer to the Google Meet. I'll try to do myself because maybe I I'm nervous about, and then I make mistake I don't realize. So thank you all for joining, and good luck on your test for your exam. Thank you. You all can leave now.